Hello, sixth graders. Welcome to sixth grade math three-dimensional figures lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your notebook. Today's objective is, I can draw three-dimensional figures by completing practice problems with 100% accuracy in multiple attempts. The standard we'll be working on today is solve real-world problems by finding surface area for three-dimensional figures using nets with fractional edges. We're going to start by looking at some vocabulary. This should be in your words worth knowing section. If it's not, you need to be sure it gets there. A solid is a three-dimensional figure that encloses a space. A polyhedron is a solid whose faces are all polygons. A face is a flat surface of a polyhedron. An edge is a line segment where two faces intersect. And a vertex is a point where three or more edges intersect. We're going to start with example 1, finding the number of faces, edges, and vertices. So vertices is just the plural of vertex, so don't let that word scare you. And so our directions are to find the number of faces, edges, and vertices of the solid. So you can see this pink solid that's sitting here. And it says the solid has one face on the bottom, one face on the top. I'm going to mark those for you. So there's one here on the top and one on the bottom. And four faces on the sides. So you have one in front here and one in the back. And then you have one on the right and one on the left. So everywhere I've put an X, there's a face. So remember, the faces are the flat surfaces. So our first step is to count the faces. So that's step 1. And there are 6 faces. 6 faces. And the faces intersect at 12 different line segments. And they've marked these intersections for you in green. And those intersections are the edges. So you can see them here, the green lines. See if I can mark those for you a little bit. So we're going to count those. There's 1, 2, 3, 4 on the top part. And then there's 4 vertical ones that go around it. 2, 3, 4 going around. So 4 plus 4 is 8. And there's 4 on the bottom. 1, 2, 3. And then there's one in the back that we can't really see, but we can imagine it being there. So 4 times 3 is 12. So there's 12 edges. And then the edges intersect at different points. So we're going to show you those different points. I'm going to put them in red so that you can see them. 1, 2, 3, 4, 5, 6, 7, 8 different points. So those are the vertices. So there's 8 vertices. So step 2 was counting the edges, and step 3 was counting the vertices. And then your answer is here. So the solid has 6 faces, 12 edges, and 8 vertices. And I've marked up that picture pretty well for you so that you can see what's what on there. Next, we have a key idea. Actually, it's 2 key ideas on prisms and pyramids. A prism is a polyhedron that has 2 parallel, identical bases. The lateral faces are parallelograms. So what that means is that when you stand the prism up on one end, the top of it is flat. And Pyramid is a polyhedron that has one base. The lateral faces are triangles. So the sides of a pyramid are triangles. The sides of a prism are parallelograms or rectangles. So when you stand a pyramid up on its base, the top of it is a point. You can only stand it on one end. And the note at the bottom of this key idea is really important. It tells you that the shape of the base tells the name of the prism or the pyramid. So in this example, you have a triangular prism because the bases of the prism are triangles, and you have a rectangular pyramid, which means that the bottom or the base of the pyramid is a rectangle. Now we're going to take a look at example 2A. We're drawing solids. So you might want to practice this on a sheet of paper because you're going to need this skill when you are solving your problems. So 2A, we're drawing a rectangular prism. Step 1, we draw identical rectangular bases. And step 2, we connect those bases with straight lines. It says connect the corresponding vertices, so you just connect the corners. And step 3, it says change any hidden lines to dashed lines. Now you might see me do this a slightly different way, and I'll model that for you here. And so when I do these, I do start with the identical bases, or I try to make them identical, but I overlap those corners. And then I connect the corners. And then when I am not working electronically, I do go back and change those to the ones that are hidden. So the ones that are in the background that if it were a real solid in real life, we wouldn't be able to see those lines. I change those to dashed lines. So mine doesn't look quite as neat as theirs does, but it works. And sometimes it's a little bit easier to keep track of where your lines go if your two bases are overlapped. So you can choose either one of those methods. They both work. And so try that a little bit on a sheet of paper, but also copy those steps into your notebook. Now we're going to take a look at example 2B. We're going to draw a triangular pyramid. So our step 1 is we draw a triangular base and a point. So you just draw a triangle and you put a dot up above that triangle. And step 2, it says connect the vertices of the triangle to the point. So you just draw lines from the dot to each of the corners of your triangle. And then you change any of the hidden lines to dashed lines, and you've got yourself a triangular pyramid. Example 3, we're drawing views of a solid. So our directions are draw the front, side, and top views of this wonderful pink pearl eraser that we have. So you sort of have to imagine that you can only see one side of it at a time. So we're going to take this one step at a time. So the front view, we'll take that as step 1, is a parallelogram. So if you're holding it sort of sideways where all you can see is the side of the eraser, that's a parallelogram. So you would draw, when I draw these, I draw a straight line, and get this going here. I draw a straight line, and then I draw another straight line about the same length underneath it, but off to the side, and then I just connect the ends. And that time it just didn't connect very well. When I have a pencil, I can erase some of that. And so it ends up being a sort of slanted triangle or a parallelogram. So that's step 1. Step 2, if you're looking at the end of this or the side view, that's a small rectangle, so you can't see from the end that it's slanted. All you can see is that it's a small rectangle, so that's our step 2. So that would just be a little rectangle. And then if you're looking at the top view, it's a longer rectangle, and that's our step 3. So practice doing some of those things on a sheet of paper. Remember, to have this flipped lesson complete, you need to be sure your notes are complete in your ISN, do your Google form questions, review the lesson if you need to, complete your Big Ideas math assignment in your Math Spiral notebook, and submit that when it is 100% correct, not before, and track your progress on your playlist.